You remember synthetic?
Somewhat.
It's a piece of cake,
It's a
huh?
lot easier than long.
Yeah, I know, it's true. And the reason that you do have to do long division is when you're doing asymptotes, which we're going to, you can't do synthetic. And synthetic you can only do when you're separated by 1 degree. So that's why you do have to learn this one. Because I remember learning synthetic, I'm like, why did you ever make us do the other? But there are times where you have to.
We're doing synthetic.
We're doing long division right now. What you don't know? Okay. So they're all going to be rational expressions. That means fractions.
Which one is this?
Long division.
Oh,
That's why I showed you that long division problem just a second ago.
I didn't know.
I know.
I got lost.
I'm sharing. So every fraction problem is just a division problem. It's the numerator divided by the denominator. So we're going to set it up as a... Oh, I am recording after all. How long has that been happening? I don't know. Poor Doobie was absent and tried to listen to the craziness happening. It's not easy. Okay, so the numerator goes inside your little divisor here, and then this is what you're dividing by that goes on the outside. That's how you set it up. I'm going to erase this now because I need room. But make sure you have that problem written down. Okay, so now we're going to start our long division. It's the same steps you just did, only I want to point out this thing right here is called a floaty. That's not an official term, that's just my term. So when you go to calculus, please do not say, is that what we do with the floaty? Because they won't know what you're talking about. But I call it a floaty because it has no involvement in the process, the division process. It's just floating on. You're only looking at the x, and you want to know you're dividing x into x squared. I think the easiest thing to do is think about what do I have to multiply x by so that I get x squared. Right now I have 1x. I need to multiply by another x. And that's what goes on top. Okay? So we did our division. X times x is how I'm going to get x squared. So if you remember, after you put something on top, you multiply. Now here's where the floaty gets to be involved, because you're multiplying times both of these, even though it's not involved in the division. So x times x is x squared. X times 4 is it's a positive 4, so that's why I put plus 4x. And then just like your other long division step, now you're subtracting. Please don't do this. You ready? Don't do that. Why not?
Don't do what? Is it negative x? You think it's negative x squared?
Yeah, so what I did is I said don't do this, and I just put that there. Why not? What? Yeah, so we want the no. Well, it's okay that we have that there because we are subtracting it, but I don't like it because the way it looks right now, don't write this down. The way it looks right now, those cancel out and you got 9x, and that's not what you should have. What happened? You see it, Sarah? What happened?
Well, because you're saying those are two positives, you're adding them.
Yeah.
9x, and then you're saying that's a negative and it cancels each other out.
Right. So the problem is I have to subtract everything. So if I just put this here, I'm only going to subtract the x squared, and I don't end up subtracting that. You have to subtract both of them. I said both like a Yankee. Did you hear it? I don't know why. It just happened. So either put parentheses around it, both. Either do that and then distribute your negative, or just remind yourself you have to change the sign of both or add your subtraction to both. I prefer that you just automatically, when it comes to subtraction, you're changing the sign. I make that negative. Hello. I make that negative and I make that negative. But you've got to do it to both. And that's what most people miss, that step right there. You've got to distribute that subtraction. Okay, now the x squareds will cancel. They should cancel. You set it up that way. Okay, so that should always cancel. 5x and a negative 4x is 1x. You can write the 1 or not. It's not really proper to write a 1, but if it helps you, please do so. Now bring down that minus 7 and start it all over again. So I remember floaty is not involved. So you're just looking at x. And you want to know, what do I have to multiply x by so that I get x? Just 1. And it's a positive 1. Because otherwise I don't want a negative there. So you put plus 1, because it's a positive 1. That's my division step. Now you're going to do your multiplication, 1 times x and 1 times 4. So I got x and I have positive 4. So here's that step again. Make sure you change both those signs. Make it negative x and negative 4. Okay, the x's cancel, and you get negative 11 as your remainder. Here's what you can't do. When you learned this in 3rd grade, you got to do this. And then somebody introduced decimals, and your life changed forever. So that's the remainder. You can't write it as a remainder because that's lame. So you have to write it as a fraction. You have a remainder, so I have a little plus sign. I'm adding a remainder. What's left over goes on top, and what you're dividing by goes right here, x plus 4. So that's a little piece you have left over. Now that's messy. And if this is a test and you've just done that, I'm not going to give you full credit because I want to see the answer in its proper form. So the answer is this. X plus 1 plus negative 11 over x plus 4. That's your answer. You could write it like this. X plus 1 minus 11 over x plus 4 because it's negative. Oops, that would be fine. Okay, so any remainder that you have gets added. The remainder goes on top, and what you divided by goes on bottom because you have that many left out of what you divided by. X plus 1. All right. Let's look at another. Record. Okay. So I'm going to my x mode. So what do I have to multiply x by so that I get 6x squared? Yeah, okay, good. So I need a 6, obviously, and I need one more x. I want 2 of them. I only have 1 of them. So yeah, good. 6x. All right. And positive 6x, because I want positive 6x squared. Now you've got your multiplication. 6x times x is 6x squared. 6x times negative 1 is negative 6x. This is the step most people miss. Change both of those signs. I should do that in red. So that becomes negative 6x, and this becomes, negative 6x squared, and that becomes positive 6x. So, bless you. Oh, that's a cough. I retract my blessing. We only bless sneezes. I don't know why. It's just what, I don't know who decided that. So I get 6x when I add 0x plus 6x. Bring down that negative 8, and you have one last time you have to go through it. I have x. Oh no. I have x. I want 6x. So I have to multiply by 6, positive 6. It was just a very emphatic, but it was just a stretch, I think. It wasn't a dissatisfaction with your life in this room, I don't think. Okay, good. So you got 6x and then minus 6. Don't forget to change both signs. You get negative 6x plus 6. So negative 2 is my little remainder. So, yeah, good. Perfect. Yes. All right, so, nope. Our final answer I'm going to write off to the side here. X squared plus 6x plus 6. And then I'm going to write a plus and put my remainder of negative 2. And it's always over the divisor here, x minus 1. And that's my answer for that. Okay, I'm going to give this one to you. This is all you. Set it up the same way. We have nothing that we need to zero out because we have x squared, we have x to the first, and we have the constant. That's the number without a variable. So everything's set up. I can go ahead and start dividing. I have 2x, and I'm trying to get 2x squared. I already have the 2. I just need one more x to multiply by. So I just have to multiply by x. Now you do your distributing. Whoop, whoop. And that gives you 2x squared minus x. Oh, yep. Something bad's about to happen. Yeah, it's happening. It's happening. Okay, we can do this. We'll going to share the experience together. Okay, we're in it together, everybody. Okay, so we have to change both signs. That makes that negative. That makes this positive. And when we add, we get 7x. I should have gone 8. No, it still would have been gross. Okay. So we have 2x, and we're trying to get 7x. We don't need any more x's. We have 1x, but we do have a problem. We have to multiply 2 by something and get 7. Okay, so 2 times something, and we want 7 for an answer. Okay, yeah, so decimals is 3.5, so you can just do decimals. What I would recommend you do is grab that calculator, and you just do the actual division. This number, whoop, this number by that number, because that's what you're doing. You're dividing this into that. So off to the side or in your calculator, 7 divided by 2, you can put decimals in here as much as I'm not normally a decimal fan. 3.5, but within a polynomial, it's more appropriate. And we don't need another x because we already have an x. It's a positive 7 that we want, so we put plus 3.5. Okay, we're not scared of that. Distribute 3.5 times 2x is 7x. 3.5 times negative 1 is negative 3.5. There you go. Don't forget to change those signs. It's the most common error to make. Change both of them. And you end up with positive 0.5. Positive 0.5. So right now our answer is x plus 3.5 plus 0.5 over 2x minus 1. Normally I would never let you use a fraction and a decimal combined, but we're going to let it ride. How about that? I mean, it just feels awful. I can't even look at it. It feels dirty.
Oh, instead you'd rather have that crazy little fraction thing over.
Well, I want this. I want that. That's what it really is. Because 0.5 is 1/2, and so that really means a 1 in the numerator, a 2 in the denominator. Like, that's what I want. Doesn't that feel good to you to see that?
That feels worse.
That feels worse too.
I like it.
Way worse. All right, we'll let the crowd win. Crowd wins. So it's no different when there's a coefficient. You just have to put a little bit more thought into it. Remember that if you need to, always resort to actual division. So you are taking this 7 and dividing by that 2. So if you're having trouble figuring out what to put, just resort to actual division, because that's what you are doing. Okay, synthetic division. Synthetic. So that's long division. Long division. We're going to go to